Today we are going to talk about matrices. In 3-6 we're going to solve systems using matrices. So we have two objectives. One is to represent a system of linear equations with a matrix, and then to solve a system using matrices. So our essential understanding, you don't have to write this down. You can use a matrix to represent and solve a system of equations without writing the variables. It's awesome. So a matrix is a rectangular array of numbers. Please write this example matrix A down. So this matrix has 3 columns and 2 rows. It is a 2 by 3, and it's read 2 by 3. You can write it as A or A with a little subscript 2 times 3. Each number in a matrix is called a matrix element. Okay, so one of the things they're going to ask you to do is to identify a matrix element. So say we have matrix A, which has 4 columns and 3 rows, so it's a 3 by 4. If they ask for A, 2, 3, remember the 2 is in reference to the row and the 3 is in reference to the column. So in row 2, column 3, it's 8. So element A23 is 8. So I want you guys to find element 13 in matrix A. Solution. Okay. So now we know what a matrix is, I'm going to show you 17. Yeah. Because it's row 1, column 3. So if you go the top row, who's in column 3? 17. So if I have a system of equations, so I have x plus 3y equals 7, and I have 3x plus y equals -8. I am going to write my x coefficients in column 1. I'm going to write my y coefficients in column 2. I'm going to draw a vertical line to represent my equal sign, and then I'm going to write my constants. If you have just the letter, then your coefficient is 1. If your letter is missing altogether, then you put a 0 there. Okay, so we are going to represent these two systems of equations with a matrix. So this first guy here, we put a little bracket. We make sure that it's x, y equals our constant. X, y equals our constant. Once you make sure you have the right form, we can proceed with our system, our matrix. So the coefficient of our x's, then the coefficients of our y's, our divider bar, vertical bar to show our equal sign, and then our constants. So step 1 is to write each equation in the same variable order, x's, y's, and then equals your constant. Line up the variables, leave space where coefficient is 0. And we'll see that in this B1 right over here. Step 2, write the matrix using the coefficients and constants. Notice the 1s and 0s. Okay. So let's look at this.
How do we know the solution though?
We'll do that on the next slide. We'll work on solutions on the next slide. I'll show you how to do it mathematically by hand, and then I'll show you how to do it on the computer using a utility. Okay, so step one is to write each equation in the same variable order. So I need to rewrite this system 4x minus y plus 2z equals 1. That's fine. I have the next one, I have 0x because I don't have any x's. So I put in 0x plus y plus 5z equals 20. And then this one, my y is on the wrong side, so I have to add the y to both sides. So I have 2x. I have my 1y. I don't have any z's, so I put 0 z's, and that's equal to 7. So once you have your x's plus your y's equal your constant, you're ready to shove that down into the matrix. So my x column is going to be 4, 0, 2. My y column is going to be negative 1, 1, and 1. My z column is going to be 2, 5, and 0. And my constant column is going to be 1, 20, and 7. Solutions. Okay. Now, to solve the system using a matrix, we're going to do row operations. Each step is going to be a row operation. Our goal is to get 1, 0, and a letter. Or sorry, not letter, a constant. 0, 1, and a constant. Or if I have a if I have 3 variables, I want to get a 1, 0, 0, and a constant. 0, 1, 0, and a constant. 0, 0, 1, and a constant. Okay, so let me explain what we can do. What is in the limits of our mathematical powers? We can switch the rows if we wanted to. And if that applies when you have 3 rows, I can put the bottom one on the top, the bottom one in the middle one on the bottom, the middle one on the top. So it doesn't, where the rows are doesn't matter. I can multiply a row by a constant. As long as I do it to the whole row, still totally fine. It's like when we find a multiplier when we're using elimination. I can add one row to the other. And when I do that, I still keep my same row, but my other one becomes what the sum of the 2 rows is. All right, so let me demonstrate to you how to solve a system using row operations and matrices. So the first thing I want to do is convert this to a matrix. So my x column is going to be 1, 2. My y column is going to be 4, 5. I'm going to have a bar to represent the equal sign. And my constant column is going to be negative 1, 4. So when I look at, I want this at the end of the day to have a 1 in the x column and a 0 in the y column and some number a in the constant column for my first row. I want my second row to have a 0 in the x column, a 1 in the y column, and a b. This is the same information that is above here. I'm just rewriting it so that you guys can, so we can use it. So if you look at our current system, I have a 1 in the X column, row 1. So I'm in a good spot. What I want to do is I want to eliminate this 2. So can I multiply my top row by -2 and then add it to this bottom row to eliminate the 2? So watch what I'm going to do. I'm going to multiply this by -2. So I'm going to get -2, -8, and 2. And I'm going to have my 2, 5, 4 still. So now I'm going to add my top row to my bottom row and replace my bottom row. Okay, so I'm going to add my 2 rows together and replace my bottom row with the result. So I'm going to go -2 plus 2. Is 0. -8 plus 5 is -3. 2 plus 4 is 6. And I am going to take my top row. I'm going to divide back out the -2. So here I multiplied it by 2. Now before I write it again, I'm going to divide by my -2 to get my first row back out. What do I want in this Y column? I want a 1. So if I divided this by -3, or I could multiply it by -1/3, I would get a 1 in that column. So I'm going to go ahead and divide it by -3. So my top one stays the same because I'm not doing a row operation on it. And then my bottom one becomes 0 divided by -3 is 0. -3 divided by -3 is 1. And 6 divided by -3 is -2. So now I've got a 1, a 0, and a 1. I just need to take care of this guy and get him to be a 0. So I'm going to take my bottom row. I'm going to multiply him by a -4 because 1 times -4 will eliminate that +4. So when I do that, I get 1, 4, -1, and I get 0, -4, 8. So now I'm going to add these two together and replace the top. So we're going to add and replace the top. So 0 plus 1 is 1. 4 plus -4 is 0. And -1 plus 8 is 7. Then I'm going to take my bottom one and I'm going to divide back out the -4. So 0 divided by -4 is 0. -4 divided by -4 is 1. And 8 divided by -4 is -2. So because this is my X column and this is my Y column, 1X equals 7. And 1Y equals -2. So my solution is 7, -2. So just do a double check. You need X, then Y equals your number. X, then Y equals your number. And in this case, we have that. So if I were to write that as a matrix, it would be 9, -2, 5, and it would be 3, 7, 17. Okay, I know that 9 is a multiple of 3, so I'm going to go ahead and multiply my bottom row by -3. And when I do, I get -9, -21, and -51. Oh, how's that for mental math brain? So I'm going to add the top row and the bottom row and replace the top. So when I add those two together, I'm going to go 9 plus -9 is 0.
But we want it to be 1, not 0.
We're going to switch the rows. And then -2 plus -21 is -23. And 5 plus -51 is -46. And then I'm going to take my bottom row and divide out that -3 that I multiplied it by. And get back what I originally had, 3, 7, 17. I'm going to go ahead and take my top row and I'm going to divide it by -23. All right, so I'm going to take my top row, I'm going to divide by -23 because I happen to know that 46 divided by 23 is 2. So, and I want, in this case, that'll give me a 1 in this column, in this element. So when I do that, it'll be 0, 1, 2. And my bottom one will be 3, 7, 17. Row operation says I can switch these guys, and because I want to be 1, 0, 0, 1 AB, I want the row with the 1 in the Y's column to be on the bottom. So we can go ahead and switch these. 0, 1, 2. Then I'm going to eliminate the 7 by multiplying my bottom by -7. -14. So I'm going to add my bottom one to my top one, replace the top. So when I add, we get 3 plus 0 is 3. 7 plus -7 is 0. 17 plus -14 is 3. And then my bottom one, before I rewrite it, I'm going to go ahead and divide that out by my -7. So I get 0, 1, 2. Last step is to take this row and divide it by 3. So my final answer is going to be 1, 0, 1, 0, 1, 2. So my x value, because this is my x column, is equal to 1, and my y value, because this is my y column, is equal to 2. So my answer is 1, 2. Okay. Let me show you how to use a graphing utility to solve a system of equations. We still have to write the equation as a matrix. can use a graphing calculator or a graphing utility. I picked old Mr. DougBabcock.com/matrix to use as my calculating tool. So so what by what matrix? So it's going to ask me when I click on here. It's going to ask me how many rows, how many columns I have. So I have 3 rows and 4 columns. And we click submit. Then we enter our values into the little matrix it creates for us. So that's 1, 2, 0, 4, -2, -8, 6, 1, 1, and 21, 4, -1. You click submit. This is called a reduced row. The last word is echelon, or no, I'm sorry, it's R row. So it's abbreviated usually R row, reduced row. So if you're looking for it, you could Google it. All right, so it took our original matrix and it performed all the row operations for us. So what it did here is it multiplied the top by -2, added it to the second one, and replaced the second one. Then it divided this row by -10. Then it then it got rid of, so -8. Multiplied this by 2 and added it to the bottom. No, multiplied this by -8 and added it to the bottom. So this performed all of the operations for us, so we get this final result. So it took me how long to punch that into the utility? Like 2 seconds. And in 2 seconds, I found out x is equal to 1, y is equal to 1/2, and z is equal to 3. You guys did this homework yesterday. How long did it take you to use the substitution or elimination method to find those answers? Yeah.
Will we be able to use that website as context?
Not for every part of it. On some problems you will be able to use the matrix calculator, but on some of them you'll have to do it the old-fashioned way. Okay, so we let the calculator figure out that x is equal to 1, y is equal to 0.5, and z is equal to 3. And go ahead and write your summary, or put your summary in, and that's the end of today's lesson.